Notes for second day of chapter 12. Please pause if necessary to fill in. Selection bias, often called undercoverage bias, is introduced when some part of the population is systematically unrepresented in a sample. For example, homeless, people who only use cell phones, or when we did the Gettysburg, and we did it just by eye, the smaller words were unrepresented. So if we were trying to get a census of how many kids in a family, homeless people wouldn't get counted because they're going around house to house or mailing out a census. So they're systematically underrepresented. Okay. Selection bias also occurs when volunteers self-select themselves for a sample. People who voluntarily respond to surveys tend to have different and stronger opinions than the rest of the population. This is often called voluntary response bias. So remember, voluntary response bias is a type of selection bias. It's just a specific type. So for example, a phone-in survey for American Idol. Lots of people watch the show, but only the people that really, really care about it call in and vote. Same thing with internet surveys. If you're kind of middle of the road, you're just going to go, oh yeah, and click X and get out of that. So it's not very representative. Okay. In all sampling procedures, it is very important that every member of the population be given an equal chance to be chosen for the sample. Random sampling is the best way to make sure that this would happen. And I would highlight that. Okay. It is important to carefully compare the population of interest, the population we want to know about, with the population of inference, the population we can actually make conclusions about based on the subjects chosen in the sample. If there are selection bias, then these populations are not the same. Okay, so it's really the people that answered our survey. That group of people are the ones that we can say, yes, they prefer this singer better than all of America, because not all of America called into American Idol. Here's another example. For example, we wanted to estimate the average GPA of students at Hillcrest. If we took a random sample of students on campus from 7 to 8 a.m., describe the population of interest and the population of inference, will our estimate be biased? And the chances are yes. Excuse me. It will be biased. Our interest population is all HH students, okay? But our population of inference is just those there in the AM. So it's either going to be the kids that are there early getting help, but in which case they are in their teacher's room, so they might have higher GPAs or lower GPAs. It might be the kids that ride the bus. So it just really depends. You're not going to get a true test of GPA. Also, seniors, unless they're in teachers' rooms getting help, they tend to come later because most of them drive themselves. So then you're just getting the lower GPAs of the freshmen because 1 or 2 Fs is going to affect their GPA more than a senior that has lots of different terms to go from. So it will be biased. Okay, here is another type of bias. This one is response bias, otherwise known as measurement bias. Okay, and response bias occurs when our method of collecting the data tends to produce values that systematically differ from the true population value in some way. For example, using a faulty instrument. If you were doing a survey on student weight and you happen to have a bad scale, okay, that's over measuring everybody, okay, it's a few pounds over, that's a problem. Or let's say you and your friend were doing a project on student weight and your scale was off but your friend's was correct, then you've got response bias. Okay, human nature. People tend to get embarrassed. So if you ask them a question that might be a little bit embarrassing, they might lie. Or if I walked up to a student and said, hey, what's your favorite class so far this year, in front of all of their friends, and let's say it's an AP Stats class, I'm putting pressure on them to say AP Stats, even though they're really not math kids and they like English. So human nature. Wording of a question. If I said, Are you in favor of welfare, which sometimes has a bad connotation, versus helping people financially until they can get on their feet? Okay, one has a bad connotation and the other a slightly better connotation. Okay, order of the questions. Just like when you take a test and sometimes you do better in the beginning until you get tired and the end of the test is worse. Okay, the order of the questions, or you say, how do you feel about candidate X? If you had already asked about somebody they like a little bit before candidate X, it might color how they respond about candidate X. So if you are voting, you should mix up all the responses if they're multiple choice, because if they read a candidate they know more about or that they have strong feelings for, when they get down to the next candidate, it might change it. But if candidate X was first, they might respond differently. Okay, and then the characteristics of the viewer. For example, if you walk up and say, a cute girl walks up to you and say, do you prefer brunettes or blondes? And she's a brunette, but you really prefer blondes. You may say brunette just because she's cute and she's standing in front of you. So these are things that we will discuss later, but you always have to keep in the back of your mind. Okay, so the next definition is non-response bias, which occurs when responses are not actually obtained from the subjects chosen for the sample. So you may say, I'm going to call every person in a neighborhood in Sandy, but when you call those numbers, okay, people hang up or they weren't home when you were called. You now have non-response bias. Maybe you called during the day when people worked, and so only people that answered the phone are people that don't work, retired people or stay-at-home moms, which is going to bias whatever question you're asking them, okay? Very few surveys, if any, have a 100% response rate, but every effort should be made to make this rate as high as possible. Personal interviews have a better response rate, but are more costly than mail or phone surveys. And that would be because if I walk up to you and ask you to respond to a question, you're more likely to do that just by human politeness than hang up on me if I'm in your face, okay? So, or if I call you. In all three methods, it is important to follow up on the subjects that do not respond the first time rather than sample more people. So it's better to call a home that hangs up maybe a few hours later and somebody else will answer. Actually, that's a bad example. It's better to call a home that nobody answered, call later, maybe when people would be home, versus calling just another house, because you call another house at the same time and you're going to get the same population, people that are home from work, versus call the original number at 5 or 6 once people have gotten home. Note, increasing the sample size is usually a good idea, but if there is a bias present, even a very large sample will probably be worthless. Okay, and we'll watch a video on that tomorrow. All right, last page. As we discovered with the Gettysburg Address, it is very important to randomly select members of the sample to avoid selection bias. I can't say that enough. Okay? There are many random sampling procedures, the most basic being a simple random sample. And pretty much everything we do will either be a simple random sample or have a simple random sample in it. So a simple random sample of size n, forever now known as an SRS, is a sample from the population that is selected in a way that ensures every member of the population has an equal chance of being selected and, all right, back to that every member has an equal chance of being selected, and notice that was pre-highlighted because it's so important. Every sample of size n has the same chance of being chosen. So let me give you an example. For example, to select a simple random sample of size 4 from this class, we could write each name on a slip of paper, mix them up, and select 4 names. In this way, each member of the population has the same chance of being chosen, as does, here's the and, each possible group of size 4. Okay, so some people might say, or here's another way to do it. I could use my roll sheet as a sampling frame, vocab word from last time, to choose a simple random sample. I could assign each member a number, and then use the random number generator to select the sample. Okay. I could also use a digit table, which we'll talk about briefly, and that's just basically somebody has pulled a bunch of random numbers out of a hat and written them down, or used a random table. And before we had simple random number generators, they would just take a table of these and say, okay, this was my first number I pulled out of the hat, this is the second number, this is the third number, and they would have a piece of paper. They'd randomly pick a number to start and go from left to right. We don't really use those anymore, and they won't show up on the AP test anymore because real statisticians will now use a calculator or a computer. Okay. So note, when choosing a sample in this way, occasionally, and this is not in the digit way, but random, okay, occasionally the same number will be selected twice if you did a calculator or a digit table. However, in most cases, statisticians do not want to use the same person more than once. This is called sampling without replacement, because after a person is selected, he is not replaced in the sampling frame. Okay, so let me give you some advantages and disadvantages. Some advantages. Each person or group has the same chance of being chosen. It's a relatively simple procedure. Okay, it's like sticking everybody's names in a hat and drawing them out. And most inference procedures we'll learn in quarter 4 are based on a simple random sample. Okay, some disadvantages. It is difficult to do with a really large population. And not so much if you can assign everybody a number on a computer and then use a computer to draw numbers 1 from 50,000. But if you had to put everybody's name in a hat, okay, and that's the basic example, that would suck if there are 400 people whose names you have to write down. Okay, and it does not guarantee a representative sample. Okay, we could accidentally over or underestimate just by chance. Okay, and so here's my little rabbit in a hat, right? Rabbits come out of hats for magicians, and he's pulling names out that have been placed in there, so he's randomly selecting names. Okay, so here's an example of why, of one that would, a way that doesn't do it with the and. Suppose that a class is half boys and half girls. To get a sample of size 4 from this class, we could write the name of each boy on a slip of paper, mix them up and select 2, and do the same from girls. For the girls, this isn't a simple and random sample, okay, because each group of 4 is not likely to be picked, okay? Each student has the same chance of being picked, but the group of 4 that maybe is 3 boys and 1 girl isn't possible when you split it up 2 boys, 2 girls. So it has to be that and idea. All right, I'm going to speed up at the end so you don't have to watch a second video. Here we go. Lastly, a stratified random sampling is a method of sampling which seeks to reduce the variability of a simple random sample by, and there's another vocab word, look that up if you need to, by selecting a random sample from each subgroup of the population. This guarantees that each subgroup or stratum is properly represented in the overall sample. So a subgroup would be Hillcrest High School is our population, juniors are a subgroup, seniors are a subgroup. Okay, they're a group inside the whole. Note, to be most effective, the members of each stratum should be as similar as possible with regard to the question of interest and very different than the members of other strata. Okay. Suppose we wanted to get a stratified random sample to answer a question about assemblies. Since freshmen may have different views than seniors, sophomores different views than juniors, etc., we want to make sure each group is properly represented in our sample. Suppose there are 600 freshmen, 500 sophomores, 500 juniors, and 400 seniors. If we wanted to take a stratified random sample of size 100, how many of each class should be included? Well, we don't want to do 25, 25, 25, 25. We want the ratio to match. So if there are 600 freshmen, okay, sorry about that, my phone rang. So again, we have this mix of sophomores and juniors, but there aren't an even number of each grade. So instead of doing 25 of each, we'd say, look at the freshmen, we have 600 out of 2,000 students, which is 30%. So we'd want 30% of our sample size of 100. So we'd end up wanting 30 freshmen. We'd end up wanting 25 sophomores, 25 juniors, and 20 seniors, okay? Once we determine the number of subjects to select from each stratum, then we take a simple random sample within each. So, and that is a common theme, doing simple random samples inside other sampling. Thanks.